Let's look at this question, how to solve this problem. It's a homework problem which was there in WebAssign. The question says that a disk with moment of inertia I1 rotates with a frictionless vertical axis with speed omega I. So you have got I1 which is rotating initially with omega I. A second disk, this one having moment of inertia I2, and it's not rotating. So for this, omega I is equal to 0. So initially it is not rotating. It drops onto the first disk. Because of the friction between the two surfaces, eventually they have the same angular speed, that is omega F. So it's kind of a collision problem, before collision and after collision. So we are going to apply conservation of angular momentum, which says that total momentum before L total before is equal to L total after. So how do we do that? Okay, so L total before is I1 omega I plus I2 multiply 0 equal to I1 plus I2 multiply omega F. Let me just write it properly so that you can understand it. Okay, let's just shift this here. So we have got this as omega F. Now if you look at this equation, it is same as the one which is shown here, because I2 multiply 0 is 0, so that gets eliminated, and then you rearrange the equation to get this final expression. The next question is asking you ratio of final kinetic energy to initial kinetic energy. So we find the final kinetic energy. Formula for kinetic energy, rotational kinetic energy, is half I omega square. So you get final, because both of the objects are then rotating with the same velocity. We are adding I1 plus I2, and initial has only I1, because the second object, if you find for the second object, the formula will be half I omega square, but for the second object I2, and this omega is 0, it was at rest, so we don't have any initial kinetic energy for the second object. Then we just find the ratio of the two. You can see that we are finding the ratio of the two, where omega F has been replaced with the help of the first part. Okay, this omega F has been replaced with the help of the first part. Then you solve, open up the brackets, simplify it to get the last step.